want you to think about the notation. Some of you in our last lesson, I showed you and talked about what the new notation was. And when you got to it, I had about 3 different people go, what does this mean? Because you weren't listening. Notation is important. When I write something like this, somebody read that as a sentence out loud to me.
Integral. Integrate the function that with respect to x.
Thank you. That is what that means. Integrate this function with respect to x, right? You're not being asked to use this little dx bit. They're just telling you that you're integrating this with respect to x, because sometimes we use other letters. Now, I also want to show you something like this. So we've been writing things like y equals 3x to the power of 4, 5, that's not what 4 is. And then dy dx is 15x to the 4th. There is another way that you could write this. This is saying the difference with y with respect to x, okay? If I just give you a function and I say integrate that, there's no y. So I would call this d dx is 15x to the 4. There's no y involved. This is not an equation. So if there's no y, don't write a y. If you're asked, so sometimes you will be given an equation, you might be told that d dx is 3x squared plus 4 on x squared, right? Something like that with respect to x. So what they're telling you is that this is the derived function, d dx, okay? There's just no y involved. It means the same thing, but they're just not giving you a y because there isn't one. Does that make sense? You could rewrite this as y equals blah, 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 and then you can use the letter y. But if they don't give you a y, that's all that means, okay? So just, I want you to get used to the notation of things. Yeah, we don't want to get questions wrong because we don't understand what they're saying. Okay, so if I said that f of x equals 3x squared minus 4x plus 7 all to the power of 6, how do I differentiate that? Yep, chain rule.
Divide by 100 and 6.
You're not listening to me, Adil. How do I differentiate this question?
Oh,
Chain rule. So what do I do? You know what? I'm actually just going to get rid of this and make it slightly easier because I'm trying to prove a point. Okay, what do I do? 6 brackets, 3x squared minus 7 to the power of 5. Good. Okay, so my chain rule says I must multiply by the derivative of this. So what do I get? And then just 3x squared minus 7 to the power of 5. Now, we obviously, when we're integrating, we're doing the reverse of differentiation. So we need to undo the chain rule. So if we've got multiple things going on and we're integrating, we have to take that into consideration when we integrate. So let me go back. I am now going to say we're going to differentiate this. So if I asked for the integral of 36x times 3x squared minus 7 all to the power of 5, with respect to x, so we're going to integrate this function now. We should end up with this up here, correct? So we know what we're going to do. So let's do it. Let's bring it down here and see if we can come back to it. So we write the same thing that we had before. What do we do to the power? Add 1 and divide by the new power. And now we're also going to divide by the derivative of this. Because when we differentiate, we multiply by the derivative of the brackets. Now we're going to divide by the derivative of the brackets. So what's the derivative of the brackets? 6x. See how I end up with 36x, 3x squared minus 7 to the 6 divided by 36x, right? That's what this is. See how they cancel out? And now I'm just left with 3x squared minus 7 all to the power of 6, which is what I started with. See how it works? So instead of multiplying by the derivative of the brackets, we just divide by the derivative of the brackets. It's the only difference. We're just reversing the process. Okay. Oh man, thank you. Okay, so there is a plus C in this situation. Originally it was 0, so it wouldn't have made any difference, right? C is 0, but you're right. I should absolutely have written plus C. That is me not thinking clearly. Thank you very much. Okay. I am going to tell you to ignore the method they're giving you for 9D. That is useful in different circumstances, not so useful to apply to today. I think it's just extra complicated. We will use the rule that they're teaching you for 9D for actual difficult things, but there's no point in just adding it to stuff that you don't need to add it to. So let's do an example. So I am going to say that d dx of 3x squared minus 4 all to the power of 8. All right, so what I want to know is, okay, so I haven't written a y, right? Because there is no y. So I just want to integrate this function. I am telling you that d dx is this. This is the differentiation, right? D dx is this. So what I want to know is what is the integral of this. So I'm going to integrate 3x squared minus 4 to the power of 8 with respect to x. So what do I do first? Okay, so I make the brackets 9, so the power 9. Then what? What do I do? Divide by the new power and the chain rule. So what am I multiplying by? 6x. Fantastic. Sorry?
Yeah, your form looks like a 9.
It really does, doesn't it? That's a really good point. Maybe I think I actually wrote 9. I think I just copied that number. Okay, so then we have 3x squared minus 4 all to the power of 9 divided by 54x. Okay. Yep, that's all I got to do. Okay, I can't simplify that any further. Sometimes they're asking you, so they're going to do a weird thing in question 1. All the questions in 9D. Thank you. Why do I keep forgetting that today?